Hi, this is Joe Pringle, VP of Customer Success with LakeFS. I want to give a quick overview of how LakeFS integrates with MATLAB and allows you to take advantage of the data version control capabilities of LakeFS from within the MATLAB environment. Now let's look at how the LakeFS and MATLAB integration works. And to do this, I'm going to go through an example and just sort of show what are the kinds of things you can do in MATLAB that leverages LakeFS. And to do this, I am going to train an anomaly detection model using some printed circuit board image data. And I've created this sort of simulated scenario where imagine I'm with a global manufacturing company and we build models to detect defects on our production lines. And in this case, I'm using kind of a simplistic example. I have 4 different PCB types, and I've imagined maybe I have 4 different facilities, and the reality would be a lot more complicated. I'd have maybe dozens of facilities and thousands of products and things like that. But I think it'll help illustrate like how data version control is useful for an end-to-end project like this. And so the first thing I'd like to do is just kind of look at how we set up this data in a LakeFS repo to support this type of project. And so what I'm going to do now is, whoops, I'm going to paste the right code in. I'm going to take a look at an existing repository here that I've set up for this. And I'm just going to, and this is where I'm using some of these little helper functions that I described in the blog post to help us query LakeFS. So let's see how this is set up. And so in this case, I have some branches set up. Again, imagining like maybe each facility or each product line for a given PCB, maybe they have their own sort of data ingestion or data prep branch in this case, where that's where I'm keeping my raw data that I'm going to use. And then machine learning teams might use different data from different facilities to build different kinds of models. Second is I have what are called tags, where tags allow us to create a snapshot of a repository, a point-in-time snapshot that allow us to understand the exact state of all the data in the repository that we can then roll back to or reproduce later if we need to. And so I've set this up in a very simplistic way, but again, most of our customers they have orders of magnitude more facilities or products, and so their structure of how they structure LakeFS to do this is more complicated. So now let's poke into one branch that we're going to use to train this first model. And so this is this hypothetical Shanghai facility. I'm going to train a model on this 4th PCB type. And I'm going to use a toolbox in MATLAB, the computer vision toolbox, and I'm going to use the patch core tools in MATLAB to build a 1-class anomaly detection model, which trains on normal images only. And this also illustrates like a very typical problem with detecting defects is often defects are very rare, and you don't have balanced data where we can kind of have this nice labeled training data set with normal and abnormal images. We're going to train on normal images only, and we're going to try to recognize the defects. And so this is set up in that way. Here's my training data. It's all normal. And then I have some defective images and normal images that I'm going to use to evaluate the model. So that's kind of the scenario. Now let's start building this model. The first thing I'm going to do is I am going to look at the metadata for this for this type of data. And that's another thing we hear from a lot of our customers is for the kinds of models they build, there's a lot of complexity. Like again, if you imagine this image model scenario, sometimes like the camera that took the image or the lighting or the resolution or other factors are really impact model performance. And so in this case, maybe I'm with one machine learning team on one side of the world, like I might need to find the exact right data with the right camera and lighting, et cetera, to build a new model for a new facility we're setting up or whatever. And so we hear from customers all the time, they're all focused on how do we use, like as we version all our data, we need to have this kind of sophisticated metadata that we can now expose to our data science team so they can find exactly the right data that matches the model they're trying to build. And next, let's mount this data. So I'm going to use, this is another one of these part of the helper file that we set up allows you to run Everest mount. And so now I've mounted this repository, actually more accurately, I've mounted a snapshot of this repo and a specific path of data that I'm going to use for this first model. And so what mount lets us do is it lets us mount a repo or a path onto our local file system. And I can now interact with it just like I would interact with local files in MATLAB. I can do everything I would normally do in MATLAB, but I'm using files from this repository, and I'm getting all the benefits of data version control in the background. Mount also does some other nice things in that it lets it doesn't download all the data, and instead it prefetches the metadata. It lets us do file operations really quickly, and it only downloads if we access a file, and then it caches that. And so it has some really nice features for large data sets from a user experience standpoint. Okay, let's take a look at this specific data that we're going to use here. So I'm going to just pop these up in the little MATLAB viewer. And we can see like here is, this top row is normal PCBs. And this bottom row is defective ones. And so I'm going to zoom in a little bit. We can see this little guy right here has some rust and it's bent or whatever. And then what's challenging with this is like we could have defects in other parts where, and that's where this type of model approach is useful for us. So that's the data we're going to use. And now what I'm going to do is I'm going to start the workflow of training a model. But the first thing I'm going to do is I'm going to create a new branch. And this is where the power of data version control comes into the picture, in that we hear from lots of customers that have lots of machine learning teams that need to use data that are controlled by other parts of the organization. And so it's hard for them to access data in a self-service way. They have to call someone or put in a ticket to get data provisioned that they can then work on. Well, lakefs helps with that because it lets us create a branch that we can experiment on without breaking anybody else's data, production data or raw, like kind of official data that other teams need to use. So I've just created a branch in my repository, and this is what we're going to do our experiment on. We also hear from customers who, on the data side of the house, the teams that manage the data, this helps them save time because they're not responding to all these requests to provision data, and so it reduces the friction from these different teams, and this is huge. So now I've created this branch that has my data on it. Now I'm going to train the model here. And so for this, I'm going to hit start on this training job, and I'm going to pause the video, and then I'm going to come back when it's done. Okay, so now the training job finished and we can see the results here. And what I'd like to do is walk through some steps in MATLAB using lakefs to version the results of this experiment. One thing I need to point out though is in this example, I didn't make any changes to the training data. I just used it out of the box. But in a typical project like this, I would be doing feature engineering. I would be changing the data. I would be doing multiple model runs and doing kind of multiple iterations until I got a model that I was happy with. So let's pretend that's the case, and that we have some new data artifacts to version. And so now let's go through the steps to load and version those in lakefs. First, I'm going to actually just save this locally in MATLAB, and then I'm going to upload this to lakefs. And then I'm going to I'm going to make a commit on this experiment branch. And so what I've done here is now I have this commit ID that shows exactly the training data I used for this model. And typically I might load the model performance or evaluation data, the model artifacts, in something like MLflow or weights and biases. And now I have this link between the model artifacts and the data, the training data. And so that helps me to reproduce this down the road or roll things back down the road. So that's sort of this key aspect of data version control that we're enabling here. Then I might deploy this model to the production branch, and we're saying, hey, this is the official training data for this model in this situation, et cetera, et cetera. So I'm going to do this merge command here, and now we've merged experiment baseline into main. We've created a tag that we can now say, okay, this is the snapshot, the point in time snapshot of the repo at this stage. So now let's fast forward a couple months, and let's imagine a scenario where, okay, there's a new facility or new product or whatever. Now we need to build a new model for this the same type of PCB somewhere else. And so we find some training data, and what I'm gonna do is I'm gonna unmount the prior version of data, and I'm gonna mount a different path, and so it now has this new path mounted locally here, and then I'm gonna go through the same steps here, where now I'm gonna create another experiment branch called experiment enhanced. So this is my enhanced model branch that I'm going to run my experiments on, and now I'm going to do another training job here. And same thing, I'm going to hit start on this training job, and I will be right back once it's done. Okay, so now this second enhanced model has finished training, and we can see the results. And in this case, you might have already guessed this, by the way, but I'm actually not a very experienced data scientist. And so, in this case, maybe I'm incredibly excited by these unbelievable results of this model performance. And so let's go through the steps once again to save and load and version the results of this second enhanced model experiment. So I'm going to save this file locally, and I am going to now load it to lakefs. And then I'm going to commit these changes to this enhanced experiment branch, or experiment enhanced branch. And so now I have another commit in my repository. And now I'm going to convince all my colleagues how great this model is, and I'm going to deploy it to production. And so now we're merging this enhanced experiment into main. We're tagging this snapshot, or this point in time, and now let's again kind of go forward in time just a little bit, and let's imagine that we not no surprise, we discovered that there was something wrong with this model, and it wasn't as great as I thought it was. It was like overfit for the data, and we need to roll it back. And this is where all this kind of all the steps we're doing, all the steps we're doing to version these data artifacts is now. This is when this becomes useful. So I can see, okay, here's my tag. So again, this is where, again, part of the, the value here is not having to do some forensic deep dive analysis of your S3 buckets or wherever these training data might live. And this is where the metadata becomes useful. So we can go back to these snapshots and we can find the exact right data to either train a new model or roll back to a model that would work for this scenario. And so that's the idea. So I'm going to do that, and I'm going to roll back to this prior tag and roll back to this prior model we were using, and again, the idea would be to resolve this issue much faster than we would if we had to go through and somehow figure out exactly what data we were using without the benefit of data version control. So that's the idea. And my primary goal here, though, was to show the way that we can do these lakefs commands from within the MATLAB environment using this integration. And I hope that was helpful. I would say if anyone has questions about how they can use lakefs in conjunction with MATLAB, we would love to hear from you. And thank you so much for watching. I appreciate it.